The position of an object is given as a function of time by the function x equals 6t minus 3t squared, where x is in meters and t is in seconds. What is the object's initial velocity and acceleration? What is its average velocity and average speed over the interval from t equals 0 to t equals 4 seconds? So let's start with the first one, where it asks of the object's initial velocity and acceleration. So we know that velocity is related to position by saying that the velocity is the rate of change of the position with respect to time, or the derivative of the position function with respect to time. So to get the function for velocity as a function of time, we'd simply take the derivative of the position function, minus 3t squared. Now if we solve this, you should get that the function for velocity is simply 6 minus 6t. And that is the function for velocity. Now to find our initial velocity, the initial velocity is the velocity when the time is 0. So initially, what is its velocity? So we simply plug t equals 0. So the initial velocity is when t is equal to 0. So 6 minus 6 times 0. So we're plugging in 0 for t. So this just becomes 6 meters per second. So the initial velocity is equal to 6 meters per second. And that's our first part. Now we need to figure out the initial acceleration. Now acceleration is related to velocity by being the rate of change of velocity with respect to time, or the derivative of the velocity function. Or you can think of it as being the second derivative of the position function. That would work too. And solving this, you'll get that the acceleration is simply minus 6 meters per second squared. And there's not even a function. It is not dependent on t. So no matter what the time is, it has a constant acceleration. So that means the acceleration stays the same. So it's initially minus 6 meters per second squared and does not change as this object moves. So the initial acceleration is minus 6 meters per second squared, and it will stay that way while the object is moving under this function. Okay, now it's asking for the average velocity and average speed. So if you remember, the average velocity is equal to the change in x, or the displacement, and this is important, it's the total displacement divided by the time interval. So this would just be the final position minus the initial position divided by the final time minus the initial time. And so the position is given by the position function. So it's position when t equals 4 seconds minus the position when t equals 0 seconds divided by the time interval of the final time of 4 minus the initial time of 0. So now I just need to plug everything in. At x of 4, when time is equal to 4, the position is 6 times 4 minus 3 times 4 squared. And the initial position is simply 0 because if t is 0, then everything in this function becomes 0. So we can just ignore that. And then if you solve this, you should get this is equal to minus 24 over 4. So your average velocity is equal to minus 6 meters per second. So I'm going to write that up here. The average velocity is equal to minus 6 meters per second. That's the third part. But we're not quite done yet. We'd still have to figure out the average speed. And now the average speed is different from the average velocity in that it does not have a negative. The speed is simply the total distance divided by the total time. So I'm just going to call speed s. This might seem a little weird because position is also referred to as s. But I'm just going to call it s for now. And remember, this refers to speed. So the average speed is equal to the total distance divided by time. So it's the distance, total distance divided by time, not the displacement. This D stands for distance, the distance over the time. So as we can tell, there is going to be a turning point where the object turns around and starts moving in the other way, because you have initial velocity of 6 meters per second, positive. So that means it's starting out moving at a speed or velocity of 6 meters per second to the right, but the acceleration is constantly accelerating it at negative 6 meters per second every second. So its velocity will eventually go into the negatives, and it will start moving into the opposite direction, or to the left. So we need to figure out when this turning point is. So we can figure that out by simply just figuring out when the velocity is equal to 0. If you remember, our velocity function, our velocity as a function of time is 6 minus 6t, where t is the time in seconds. And we need to set that to equal 0, as that's when it's going to be starting to move left. And now we just need to solve this for t. So solving this for t, you get that t is equal to 6 over 6, which is equal to 1 second. So the turning point is when the velocity is equal to 0, and it is equal to 1 second. So we can get rid of this. So now, say that the distance it travels before the turning point is going to be change in x1. This is going to be equal to the absolute value of the position at 1 second minus the position at 0 seconds. Because this is the distance traveled, and the distance traveled is never going to be negative. It's always positive. So we just need to figure this out. This is equal to the absolute value of 6 times 1 minus 3 times 1 squared. And this just becomes 3 meters. So that's our first part. So the first part before the turning point, the distance it travels before the turning point, is simply 3 meters. And then we need to calculate the distance it travels after the turning point. So it is simply from t equals 1 second to t equals 4 seconds. And that is after the turning point. And then we just apply the same thing again. Change the distance traveled after the turning point, let's call it change in x2, simply equal to the absolute value of the position function when time equals 4 minus the position function when time equals 1. And then we just plug everything in. It's the absolute value of 6 times 4. Well, we already actually calculated this, so we don't actually need to resolve it. We calculated this one to be minus 6, I believe. No, sorry, it's minus 24. Earlier, when we were calculating for average velocity, we calculated that it traveled minus 24 meters total displacement. So, and then let's subtract that from the position at 1, which we just calculated to be 3 meters. So this becomes the absolute value of minus 27, or just 27 meters. So the distance it travels after the turning point is equal to 27 meters. Again, this is not negative because you don't really have a negative distance. Distance does not take into account the direction. It's not a vector. It's just a scalar. So now we can calculate the average speed. So the average speed is simply equal to the total distance, which is the two displacement, or the two distances that we just found, divided by the time interval. Time interval is 4 seconds again. So this becomes 3 plus 27 divided by 4, which equals 30 divided by 4. So your average speed is 7 0.5 meters per second. So, where's everything here? Your average speed is equal to 7.5 meters per second. And if you think about it, this would make sense since it's based on the total distance. And if we think about this being the object, and then it goes here, and then it turns back and travels all the way over there to that point, with this part being the turning point. If you think of the total displacement would just be from its starting point to here, because it's just going there. Its final position is there. And it doesn't matter if it goes that far or like all the way over here. If it ends up there, its displacement is just going to be that position point over there. The distance is different though, since he's going over here and then having to go back again. So it travels a greater distance in the same amount of time. And that is how you would solve this problem here.